Now we're going to look at the velocity vectors for general plane motion of the cylinder bar. I'm showing you three images here referring to the um, way how we can obtain the position vectors, velocity vectors, and acceleration. We just did the position vectors. Now we turn to the velocity vectors calculation. Now at point of interest at A, G, and B, D is the velocity components in Cartesian coordinate system. At A, G, and B, and for the x component we have dot there. This refer to the x component velocity, and y dot will be the y component velocity. So at other location we're going to evaluate um, the angular speed, and now we're going to evaluate that the angular speed will be in that direction, because if we want to evaluate the position G from A, the angle is measured from that location, right? That location. Similarly, if you want to evaluate B from G, D is the radial location, and we evaluate the angle from that position, right? Uh, we have shown that this angle is 240 degree, and the R component will be given by R dot, and the uh, angular component will be R theta dot, right? So for velocity at the origin, V O will be 0I plus 0J, because in the question it says that before um, the force 30 pound is applied to the end A, the system is at rest. And then similarly we have the velocity of A will be equal to 0I plus 0J, and for V at mass center, this one is also 0I plus 0J, and for VB the absolute value will be 0I plus 0J. But when we look at this equation, it does not tell us about the angular speed, so we need to rewrite the equation for mass center and the NB in the form of angular speed, and then we want to prove that the angular speed will also 0. So this is the thing that we need to do afterwards. So we're going to this, I write again because we're going to use this information to evaluate the velocity at mass center and P. Right, the velocity at a mass center can be written as V absolute velocity of an A plus the relative velocity of G relative to A, right? So so if you look at these equations, these figures, the velocity of G here, it has component of radial component and angular component, and if you want to convert the spherical polar coordinate system into the Cartesian coordinate system, the angle is taken from the horizontal line here, which is coincide with x component, and then we can obtain the values of the velocity. So this one can be written as 0I and 0J for absolute velocity there, and then we have cos 240 sine 240 minus sine 240 cos 240, and then we have r dot and the radius location between point A and G, and is the angular speed. So our system here having a rigid body, so the value of the distance here does not change. So we can say that the time rate of radius there will be equal to 0, and we have that 0, 0. Just now we have done the calculation when we multiply with r dot here. This one will give a value of 2, right? 2 theta dot there, and I'm going to use the symbol lab software to calculate the values. So we have 2.2 cos 140, and then sine 240 cos 240 degree minus sine 240 multiply with the 2 by 1 matrix. We have 0 there, and I just put here a value of 2, maybe x there, and then so we have the solutions, which is square root 3x and minus x. Theta and minus theta dot. So this one we've already found before is 0 because at rest. So from this equation we find that in the x component or in y component exactly, right? So we find that the theta dot is equal to 0. So we can write again the whole evaluation there. Right, so this is the body of the system. We have A there, G and B, and theta dot equal to 0 radian per second.